This video is going to talk about the angle and tip tolerance options found within the detailed options section of the Revo Mill Builder. The video covers how and why you'd want to change the angle and tip tolerance settings. You can see on screen here we've got a ring design that's got some hollowing required and has some detail that would be ideal for the base clamp option with the 8 sides, the 8-sided approach. And so I've proceeded in the builder to the detailed options section for the base clamp strategy. In the detailed options section, you can see each separate part or load part has been separated out, allowing you total flexibility and control over every aspect of every load part of the job. You can double click on any load part and change settings, alter settings to have more control over the milling. The base clamp strategy has 5 separate load parts. The first one is the cutout edge curve, cutout edge on base clamp, which is when the mill comes in and follows this upper section, removing excess wax. The mill then pauses for you to remove the wax chunks. The second section is the cutout center, where it mills the center section. Actually, that's when it pauses, and then allowing you to remove the center plug and the side chunks. The third load part is the hollow section, where it comes in and hollows the inside of the ring. The fourth is the horizontal cut on the base clamp, and that's when it comes in and mills out the top section. And the fifth and final pass is the 8 sides on the vertical with the vertical spindle, and the 8 subparts. If I double click on the load part 5, it'll open up 8 load parts, and I can double click on any of those subparts and control every single aspect of this job. Now in this example, I'm going to look at the horizontal cut, flat on base clamp with the horizontal, and I'm going to click on top of the cutter option to expand the cutter options within the detailed options section. This is where I designate what cutter I'm going to be using for each step. Now here we've got the default Revo 10-degree cutter option selected, and I'm just going to access my layer menu by typing layer in the command line, which gives me access to the Rhino layer menu. Rhino layer menu takes some time to get used to, but you can toggle the show and hide option, or the on and off switch are represented by this little light bulb, and I have a 10-degree cutter representation turned off on layer 4, so I'm just going to toggle that back on, and we can take a look at it in the side view. So you can see we've got the 10-degree cutter here. Moved it. Oh well. Now here, the 10-degree cutter option, in an ideal world, when we manufacture these cutters, a 10-degree cutter would be perfectly 10 degrees each and every time it came off of the machine that it was manufactured on. Unfortunately, we don't live in an ideal world, and sometimes there's a little bit of variation in the cutters, and the angle and tip tolerance allow you to compensate for that variation. By changing the angle tolerance, you're adding degrees to each side of the cutter. So you can simply, for example, if I wanted to tell the mill or fool the mill into thinking that I'm using a 10 or a 13-degree cutter, when in all actuality I'm using a 10-degree cutter, I could add some angle tolerance to the side of the cutter. For a 13-degree cutter, I would add 1.5 degrees to each side of the cutter, resulting in a 13-degree cutter. Clicking the set option tells the software to compensate 3 degrees total for the cutter. And that is represented here. Let me see here. Let's move this. Oops. I'm going to move my cutter back to where it was. And you can see the red here on screen represents a 13-degree cutter. So an additional 1.5 degrees has been added to the cutter. And if we zoom in, you can see at the tip, that's barely any extra material. But as you move up the cutter, the degree increases, okay, adding more tolerance to the cutter. So what this is going to do is it's going to force the mill, or the software will force the mill to step out slightly and force it to really cut with that tip. Typically, when you're cutting with the mill, you don't want to cut with the side of the cutter. You really just want to approach the geometry with the tip. So as the cutter moves down here, you'll see when it gets to about here, it's going to start moving out more, thinking that it's wider than it actually is. So allowing you to compensate and tell it that the angle of the cutter is wider than it actually is. This is particularly useful when the cutter is plunging really deep into a cavity in your design. Okay, so you want to ensure that you're not accidentally or inadvertently hitting the edge of the project. So in this case, the top down cut, when it goes in and mills the center section out of this bezel, we can ensure it's not going to clip any of the geometry by adding a little bit of tolerance to the angle of the cutter. The tip tolerance works the same exact way. The tip of the 10-degree cutter is 0.1. If I want the mill to think that it's 0.3, I can add 0.2 to the tip tolerance. Click the set button, and now the cutter is going to think that the tip is actually a little bit bigger than it is. You may wonder why you wouldn't want to just enter into the cutter library and dummy up a 13-degree cutter. In other words, enter into the cutter library, create a cutter, call it a 10-degree cutter, but change the dimensions or the angle of the cutter there in the cutter library to represent a 13-degree cutter. And it's a perfectly legitimate way to do it. If you're already thinking in those terms, you know, you're one step ahead. So the thing to keep in mind is each load part, if you change the cutter for any load part, the mill's going to pause and expect you to actually change the cutter. By utilizing the angle or tip tolerance, you can make those changes without the mill pausing. And if you're curious how to go in and change and alter the cutters in the cutter library, please refer to the video that covers how to change cutters in the cutter library. So it is a really useful tool, and what you'll find is that the programmers have spent a significant amount of time finding, examining each strategy and setting a tip tolerance and angle for each strategy's load parts. For example, if I wanted to run this on a dual plus rotary instead of a base clamp, which obviously base clamp is going to clean up the detail a little bit more, but in this case, the rotary section, automatically the programmers have put a 1-degree tolerance and are cutting that rotary portion of the job with a 12-degree cutter, forcing it to cut with the tip as opposed to the side of the cutter, which is always a good thing. I hope that gives you some insight into how and why you'd want to change the angle or tip tolerance of the cutter. And, feel free to go in and experiment. Know that we have spent, a significant amount of development time, trying to set up good default values for each separate strategy, but there's always an exception to the rule. So I think you'll find the angle and tip tolerance settings are an asset to the program and really allow you total control over the toolpath.